Hi, everyone. Today we're going to jump in and deal with two other operations with regards to rational expressions. And you can see the title on the top. We're going to go through and we're going to add and subtract our rational expressions. So similar to yesterday, I want to go through a couple background problems for us. I want you to go ahead and copy down problems 1A through C. And then I want you to pause the video and get full solutions for each of those three. We should be good to be able to answer each of those three and fully simplify. Okay, pause the video now. Okay, we're back. So, taking a look at the first one, we recognize we have a half plus 3/5. Those are different size bits. In order for us to go through, we've got to make them the same size bits. So I'm going to change them into tenths. There's my common denominator. That means my first fraction, 1/2, gets changed to 5/10. My second fraction, 3/5 is going to get changed to 6/10. And now when I simplify that, I have my 11/10. I'd like to just maybe motivate you. I would hope that we don't have to go like times by 5, or times by 2, times by 2. That if you have that written on your page, that's fine. But I think that we're just putting it down out of habit. I think you're capable of going through and coming up with those values, converted into tenths, without writing down that work. We can do that in our head. So I challenge you, moving forward, try to do it without writing that. Okay, we take a look at B. B, I've got different size bits again, thirds and fourths. So my common denominator can be 12. That means that my first fraction, I multiplied my bottom by 4, so I have to multiply my top by 4. My second fraction, I multiplied the bottom by 3, so I got to multiply my top by 3. And we come in on that, and we should be good. Can't simplify any further. Okay, now we come to problem C. And really, the reason I wanted to throw on C wasn't because it was subtraction. It shouldn't make really any difference between addition or subtraction, but rather your choice of denominator. That I really, really hope that our common denominator that we chose was 18. Now, I just want to talk about why we have 18 as our common denominator, or our best common denominator, or our lowest common denominator. I know that in the past, and I'm going past like way back, that maybe in grade 4 or 5, you would have taken 6, and then you start to kind of like write out your multiples. So maybe you go like 6, 12, 18, 24, ... And then in 9, you would start to write out those. And as soon as you got two of the same number, then that became your common denominator. Now, I hope that we recognize that your lowest common denominator is just your lowest common multiple. But if we are writing that still, then I think we've got some work to do. So you could have defaulted to a common denominator of 54 by multiplying the two of them together. I'm just going to warn you a little bit that in this instance, yes, it generates larger numbers. It will guarantee that you have to reduce your fraction. However, as we start to grow with that, if that is our strategy, we might actually create some problems we don't have the means to solve. So I want to come back then to our 18 and just discuss why 18 is the lowest common multiple. It should be getting to the point that it shouldn't surprise you. It should almost be like annoying to you by this point that for us to come up with the lowest common multiple, what we really want to do is factor. That when we take a look at 6, 6 can factor into 2 times 3. 9 would factor into 3 times 3. And so what our lowest common multiple actually means is each number, its factors have to be represented. They have to be there. So for instance, when you take a look at those red factors, for me to get my common multiple, they have to contain the factors of each. So my lowest common multiple has to contain a 2 and a 3 because I need that to include a 6, to be a multiple of 6. Well, now when I scan my way down to 9, 9 requires 2 factors of 3. Well, I already have 1 factor of 3. I got that from the 6. So that kind of takes care of one of those factors. All I need is 1 more factor. Now, all I'm going to do is just delete those green because I want us to see that that common multiple contains both values. Notice, there's your 6. There's your 9. And if we calculate 2 times 3 times 3, then there is our value of 18. That's why 18 is the lowest common multiple. It contains the factors of each value. So I am hoping that we picked 18ths, and the rest of that is just automatic. You multiply the 6 by 3, so multiply the top by 3. You multiply the 9 by 2, multiply the top by 2. That gets us to our negative 1/18th, and we should be good. Okay. What we're going to do is we're going to take a little turn today, similar to what we did last time. In order to do that, though, we've got to talk a little bit of theory. So we've spent time addressing restrictions. Restrictions on our rational expressions to ensure that our expression has the same value as a given expression. And so we just need to make sure that we're good on restrictions in this instance. Notice my operations in the middle. We're talking about adding or subtracting fractions. And I'm hoping that we can see that our only restrictions in that red case would be that b cannot equal 0 and d cannot equal 0. My only 2 division operations are here and here. And so if adding or subtracting fractions, rational expressions, I don't even have to worry about my top at all when I'm trying to determine my restrictions. My restrictions come from the denominators alone. Okay, now that we've had that quick discussion, I think we're good to jump in on what the problems are really going to look like for this topic. So what I would like you to do is copy down question D and E. I think you can see the relative spacing for both. And then I want you to pause the video and just give D a shot. Okay, so copy down D and E, and then I want you to try to come up with a solution for D. Pause it now. Okay, we're back. So we take a peek. We notice that we're dividing by different things. Our denominators have different, our fractions have different denominators. So we got to get the same size bits. That means we need a common denominator. Hopefully we came up with a common denominator of x squared y. Now, this is still new to us, so I want to make sure that we're good as to y. If I was to factor the first denominator, I need 2 x's. So I need an x times an x. There's my x squared. But to make sure that I have enough factors to represent my second denominator, I need to have an x and a y. Well, I notice I already have an x, so I don't need to include another one. The only thing else I need to include is my y. And again, there's my x squared. There is my xy. Both denominators are present. So I'm going to get rid of all those circles and actually get rid of the green. That we should be good to jump back to an x squared y common denominator. The rest just becomes purely mechanical. What did you do to the x squared to change it into x squared y? All I'm asking myself basically is, what's different between those two things? Hopefully we can see it's the y, so I multiply my top by y. Now I come to my second fraction. What's different between these two things? Well, it's the squared on the x. That means I need another factor of x in there. So I better multiply my top by x. And there we go. Notice we can't reduce that fraction any further. That is fully reduced. The only thing left for me to consider, tack on my restrictions. I just don't want to kind of bleed into question E, so I'm going to put my restrictions down below. Where do I always look? My first factored form, and notice that both of those denominators are factored They're one term. So I have to make sure that x can't equal 0 or else the first fraction's undefined, and y can't equal 0 so that the second fraction isn't undefined. There we go. Okay, hopefully we were good. We came up with the blue expression with the green restrictions. What I'd like you to do, now that we've walked through that, I want you to give E a shot. So go ahead, pause it now. Okay, we're back. So, same thing. We recognize that we're not dividing by the same value, and we're going to need to get a common denominator since we're adding or subtracting. We take a look at our denominators, and here's how I'm going to build my denominator. So I'm just going to do this one a little different. I'm going to take a look and I'm going to say, okay, I need all parts of that first denominator. So I need to include an x in my common denominator. I now need all parts of the second. Well, I notice that x and y squared don't share anything. So that means that I need to include the full y squared. Now, let me just get rid of my circle. There we go. Now I come down to the last denominator, and it has to include a 4y. Well, I notice in my green, I've already included a y. In fact, I've included 2 of them. I've got a y squared. So I don't need to include any more y's. The only thing that's missing would be my 4. And there is my common denominator. Now I'm just going to get rid of my circle, and I'm going to get rid of that whole green. And I'm hoping that we came in on a 4xy squared as our common denominator. Now, if you're still doing this today and going, okay, so what's different between my first denominator x and my last denominator 4, and we're going, so that means I multiplied it by a 4 and a y squared, so then I have to multiply my top by 4. I'm going to say, okay, but I would really hope that we can avoid that and simply just ask ourselves the question. So, what's different between those two denominators? It's a 4y squared. Okay, so what I'm going to do is I'm going to multiply my top by 4y squared. That gives me a 12y cubed. Now I go to my second denominator. What is different between those denominators? It's the 4 and the x. So I need to multiply my top by 4 and x. Now I look at my last denominator and say, okay, what's different between those two denominators? Well, I notice that they both got a 4, an x. Well, my blue denominator has a y squared. My white denominator only has a y. So the difference is xy. Okay, then what I need to do is multiply my top by xy. Now, notice your sign in between. Since I'm subtracting that last fraction, then I'm going to subtract my top being changed, so my 2x minus 1 being multiplied by xy. And there we go. Okay, the only thing left for me to do is just clean up the top a little bit. So I'm going to go ahead, I don't like that y, and I'm going to expand those brackets at the end of the top of that fraction. And there we go. If that's a squared. And there we go. So you take a peek at that, and you'll also notice that I cannot reduce that fraction any further. I take a quick peek. Do I have anything in common in the top and the bottom? Almost all of the terms have an x, but that first term doesn't. And all the terms don't have a y, almost, but 28x squared's missing one. And 4, 12, 28, 2, and 1, they don't have a common factor I can divide out. That is fully simplified. Okay, the only thing I need to remember, tack on my restrictions. X can't equal 0 or else the first denominator is 0, therefore undefined. And y cannot equal 0 because then the second or the third fraction would both be undefined. Okay, hopefully pretty straightforward. We're going to keep building. Okay, here comes the next ones. So, same thing as before. What I'd like us to do is let's copy down both of those problems. And then I'd like you to give F a shot. Okay, so once you have those copied down, then I want you to go start to finish and try to fully simplify F. Okay, pause it now. Okay, we're back. So the first thing that I think we should notice, those denominators are completely different. We've been asked to subtract them, so I need to get a common denominator. Well, that means I need to include all the factors of the first denominator. Well, that would be the whole first denominator, x minus 3. And now I need to include all the factors of the second denominator. Well, I noticed that x plus 1 is factored. Like, there's no common factor in there other than 1, but factoring that out doesn't help. So therefore, I have to include all of the second denominator. So I just want to draw to your attention that really what we're dealing with is we're dealing with a question like 1a or 1b, where the only way to get a common denominator between the two fractions is to multiply them together. Okay, now what we're going to do is we're going to make sure that we manipulate our tops to keep our fractions with the same value. So I'm asking myself that same question. What is different between x minus 3 and the blue denominator? Well, it's clearly the x plus 1. So I need to make sure that I multiply my old top by x plus 1. So my old top was x plus 5. I need to multiply that by x plus 1. Okay, now what's different between x plus 1 and my blue denominator? Well, it's the x minus 3. So I need to multiply my old top by x minus 3. I just noticed that I'm subtracting those two values. And there I go. I've got it down to one fraction. Now, I take a look on top, and I notice that I have multiple terms. I've got my x plus 5 times x plus 1, and then I've got that minus in between. So I can actually collect like terms on top. So my next job, expand all my brackets on top, collect like terms. So if you hit a snag getting to that point, let's pause it now and see if we can finish it off. Okay, we're back. So I'm going to expand. And now we're about to get to the most common mistake we could make. And I hope that you can see the common mistake that I just made. Let's take a look at the first blue line. And notice what that says. It says take this term and subtract the last term. And I want you to notice that my last term is x squared minus 5x plus 6. However, my first blue line says subtract that whole thing, and you'll notice I didn't subtract that whole thing. I only subtracted the first term. So you have to know for yourself what is going to be your mistake and what is the best way for you to avoid that mistake. Are you very conscious and you say, okay, I got to subtract the whole thing, so you do? Or are you going to want to put brackets around there to remind yourself to subtract it? It's your call. I'm going to skip over that step because I think we should be good to be able to go through and not have to put the brackets. It just requires one extra line. So I'm going to expand my brackets. X times x, there's an x squared, subtract it. Now when I get my middle term, I'm going to get a negative 3x and a negative 2x. There's a negative 5x. Subtract it. So it becomes a positive 5x. When I expand my constants, I get a positive 6. Subtract it. And there we go. We can come in on that on one line. Okay, let's go ahead and simplify. My x squareds are going to cancel out. And I get 11x minus 1 as my new numerator. And I won't be able to collect anything on the denominator. It is one term. Leave it factored. Okay, the only thing that I forgot to tack on, my restrictions, and we make sure that we look back on the first factored form. And therefore, I can tack on that my x cannot equal 3 or negative 1. There we go. Hopefully we got down to that same thing and we match up. And that's going to feel like a really common rational expression problem. Okay, so what I'd like you to do now, go ahead and try it with G. Okay, work your way down, final simplified form, pause it now. Okay, we're back. Now, I might have spoke a little too early when I said that the last one would feel common. I think G is going to feel common. We may look at that right now. We may say, okay, so I need my common denominator. So I need a full 2x minus 6. Well, I don't see anything in common with my x. And now I need a full x squared minus 9. And we would have been mistaken. Yes, 100% correct. That gets you a common denominator. But that one's not our lowest common denominator. So I'm going to get rid of that so we can see why. I would argue that this is going to feel like your most common start to most of these simplification problems. That is, let's see what makes up each individual denominator. So I'm going to take a look at that first denominator, and I notice that I can factor out a common factor of 2. I also notice that my denominator on the second fraction is a difference of squares, so that's going to factor into an x minus 3 times an x plus 3. There's my conjugates. Now we might be able to see, oh shoot, there was a common factor in there that maybe we didn't see. Notice your x minus 3's. That's a factor that's in both. So what I'm going to do is I'm going to now build my common, or my lowest common denominator. Okay, I need all parts of the first denominator. So I need both the 2 and the x minus 3. That takes care of the first fraction's denominator. Now I need to include all parts of the second denominator. But I notice I already have an x minus 3 included. So I don't need to put in another one. The only thing that it doesn't have is the x plus 3. We should be good to be able to see there is your 2x minus 6. There is your x squared minus 9. That's why the blue is the lowest common denominator. So if we didn't have that, then we can make some adjustments. And I'd like you to go ahead and try to finish off the problem again. So go ahead, pause it now. Okay, we're back. So now I'm playing that game of what's different between my denominators. So I look at my first denominator. I look at my blue denominator. What's different? The x plus 3. So I need to take my old top and multiply it by x plus 3. But I know that no one is going to write down 1 times. They'll just leave that as their x plus 3. Now I take my old top, which would have been a minus x. And I need to see, well, what's different between the old second denominator and the new blue denominator? Oh, well, it's that 2. So I need to multiply that old top by 2. Now, we don't necessarily like that form very much, but we're okay to write it there. Now our whole goal is to simplify. So on top, I'm going to have an x minus a 2x. So that becomes a negative x. And then I have nothing to collect with on my plus 3. And we get down to that point. Nice. Okay, I'm hoping that I had some of you that didn't stop there, because you can see that we could actually reduce that further. Look at the top of my fraction, and I'm just going to shrink down my fraction to give us a little more room. Look at the top of that fraction, and do you notice that it's a negative x and a positive 3? And I almost have the same thing on my denominator. I notice that both of my denominators, though, start with positive x. So I might be motivated to factor out that negative 1 from both terms on top. And now that my my numerator is factored, I can see if I can divide out any more common factors, and I notice that I can actually divide out an x minus 3. Okay, so my blue fraction actually reduced a little further. It reduced to a negative 1 over 2 times x plus 3. So this is just an example of, hey, you were given two fractions. You were asked to subtract them. And when you did subtract them, you found you could reduce your final answer. There we go. That's all that happened. Okay, I'm hoping that nobody forgot to tack on the restrictions. I know that x cannot equal, and I always go back to my first factored form. And all I need to focus in on is the plus or minus 3. Okay, I would say I think G falls into your very common problem. Okay, we're going to tackle a few more. So I want you to take a look at H. What I want you to do is I want you to copy down H and then try it on your own. We should be good to go start to finish on this one. I think it'll be a good gauge for you. Okay, pause it now. Okay, we're back. So first thing I would look to do, let's try to factor it and see what's in those denominators. So my first denominator I can factor. That's a simple trinomial. X minus 5 times x plus 3. My second fraction, I have two terms, but there is a common factor of x in there, and so I can factor out an x. Okay, I notice that there is something in common in both of those denominators. So my common denominator has to have an x minus 5 and an x plus 3, all parts of the first denominator. And now I just need to include in anything that's different. So what's different between my x times x minus 5 and what I have on the bottom? It's just the x. That's the only thing that's different that isn't included in that denominator. So that means I got to put in another x. You can see both denominators in the blue. We know we're good. So let's just make sure that we change the tops the same way. So what was different in the first red denominator from the blue one? It was just that x out in front. So I need to make sure that I multiply my old top by x. Okay, what was different in my second denominator to my blue denominator? I notice it's that factor of x plus 3. So I need to make sure that I include another x plus 3. So take your old top and multiply it by x plus 3. Now the rest is just like straight, almost shut your brain off algebra. So let's go ahead, expand our brackets. Second one, I'm going to get a 5x squared. I'm going to get a 15 minus 2 of them. So there's a 13x minus a 6 all over that ugly denominator. Now I can go ahead, reduce my top. I have a 6x squared plus an 18x minus 6 all over x times x minus 5 times x plus 3. Okay. Well, maybe this problem is done. Maybe it's not. Like maybe that fraction reduces further. I got to examine that. So the only thing that's not factored is my top. So I need to spend some time factoring my top. Here's where I need to draw to your attention the expectation and to bring you back to what are we actually doing in the problem. I hope that we can see that there is a common factor of 6 in all three of those terms. So I could factor out a common factor of 6. Now, I'm just going to write the bottom in, but I would never be writing this gold. I just want to draw to your attention. Take a look at the 6 on top. Is there a common factor of 6 on the bottom? No. So I don't care about factoring out a 6. Could not care. Because it wasn't a factor in the bottom. That I don't have the instruction to factor. I have the instruction to simplify. So all I care about is there a common factor that will divide out? So when I get to my remaining trinomial, I don't care if it factors. If it doesn't factor into one of these. And very quickly, when I say two numbers of multiple, look at my constants, 3 and 5. There's no way that I can get a 3 or a 5 out of a 1. So the fact that that blue expression factors to give me the gold, I don't care, because it doesn't factor into something useful. There's no common factor, top or bottom. So my blue expression is fully simplified. Nice. The only thing I need to do, tack on my restrictions. This should be automatic for us. We're looking back on first factored form. And so I have that x cannot equal 5, -3, or 0. Okay, we got one more. Okay, I'd like to leave you with I. So I want you to be able to work your way through I. Copy the problem down, simplify it. Let's answer this one as if this was a test question for us. This will be a great gauge. Okay, pause it now. Okay, we're back. So there are a couple little mechanical mistakes you could end up making in this problem. If you make a mechanical mistake and you find that it gets corrected, then you make the adjustment, pause the video again, and see if you can finish it off. Don't ever lose an opportunity to see if you can do it on your own. Okay, so we take a look, and we're going to factor our first denominator. Let's see what's in there. A minus 6 times A minus 3. Second fraction, let's do the same thing. And I have an A minus 6 times an A minus 4. Okay, if we made an error in factoring, change it, finish it off on your own. Otherwise, here we go. So I now need my common denominator. It has to have all parts of the first fraction and all parts of the second fraction. Well, the only thing that was missing between the first and the second is that A minus 4. So you can see your common denominator. There's your first one. There's your second one. Okay, now we're playing the game of how whatever we did to the bottom, do the same thing to the top. So the only difference between my first denominator and the blue is the A minus 4, so that's what I have to multiply it by. The only difference between my second denominator and the blue was that A minus 3, so I got to multiply. And now we get to that point, we should be good to just expand and collect. So I got an A squared minus 4A. We're not going to make a sign mistake here. We're going to expand our bracket. So A squared, subtract it. When I get my middle term, I'm going to get a negative 5A, subtract it, so it changes signs. I'm going to get a positive 6, subtract it. And that gives me now I got to collect. Ooh, it's nice. My A squareds cancel out. And I get down to an A minus 6 over A minus 6 times A minus 3 times A minus 4. Now, if we got down to that point, I think we did well. However, I'm hoping we noticed that our A minus 6s are going to divide out. Nice. This one reduces further. That's going to give us a 1 over A minus 3 times A minus 4. And as long as we remember our restrictions, A cannot equal 6, 3, or 4. Now, okay, hopefully I went well. If we made a silly mistake, we were able to get back on track. And now we've added in, adding and subtracting as our operations with our rational expressions. So same thing as normal. Your job, jump in, get some practice, make sure you're good with it. Good luck.